Hey there, it's ChemGal, and in this video, we're going to talk about H NMR signals. Have you ever wondered how many signals a compound is going to have on the H NMR spectra? Well, this video will explain how. With H NMR, each hydrogen environment corresponds to one signal on the graph. Let's go ahead and see what we mean by that. Let's take a look at the first example. We see that there's one hydrogen environment here with that CH3 group. There's another hydrogen environment over here with that CH2 group, and a third hydrogen environment here. So we know that this compound has 3 H NMR signals. So when we pop this guy in the H NMR, we're going to see a graph coming out with 3 signals. Let's go ahead and try the next one. We have one hydrogen environment here, one here, one here, and one here. So this H NMR spectra is going to have 4 signals. Take a moment to try the third one on your own. So here we have one hydrogen environment, we have another, we have all these hydrogen environments. And so we see that this compound is going to have 1, 2, 3, 4, 5, 6, 7 H NMR signals. Now let's talk a little bit about symmetry and how that affects how many signals we have. So let's take a look at the first one on the right. We see that we have one hydrogen environment over here. But because of the symmetry of this molecule, we see that same hydrogen environment here. And we also see another hydrogen environment here and that same environment over here. What do we mean by this? Well, if we look at the molecule, we see that there is a plane of symmetry going down the middle of it. This particular hydrogen environment is no different than this one, and that's because these 3 hydrogens have the same exact connectivity as these 3 hydrogens. Both of them are attached to a carbon that's attached to a CH2 group and attached to this carbonyl group. Likewise for this guy, these 3 hydrogens are attached to this carbon, which is attached to a CH2 group, which is attached to a carbonyl group. And so because they're attached to the same things, they're technically the same hydrogen environment. And remember we said earlier that each hydrogen environment will correspond to one signal on the graph. Therefore, these 2 hydrogen environments are only going to make up one signal. So because they have the same connectivity, these are also the same hydrogen environment, and they are also going to make up one signal. So we'll go ahead and say that this compound will actually have 2 signals on the H NMR spectra. And if you wanted to label them, we would say that this would be signal A, this would be signal A, and this would be signal B, and this would be signal B. Now let's go ahead and try the next one. So over here we have this hydrogen environment. We'll color the next hydrogen environment a different color. And we have this hydrogen environment here. Now, this hydrogen environment is the same as this one and this one. And that's because there's a different kind of symmetry going on here with this specific carbon. Remember that this is a single bond, and single bonds are free rotating. So these guys can rotate in any direction. And so they all have the same connectivity, where they're all attached to these carbons that are attached to this carbon, that are attached to this carbonyl, and to this CH2 group, and this CH3 group, and so on and so forth. They have the same chemical environment, and they're all going to count as one signal. All these guys will count as one signal. So if we wanted to label them A, we would say all of these are A, and we might call this signal B and this signal C. So this compound here has 3 H NMR signals. Now take a moment to try the next one on your own. So here we have our first signal. There's symmetry in the molecule that we want to take into consideration. Going down the structure, we might say that the first signal we have here is signal A. We might then say that the next signal here is the same environment as this hydrogen over here. And so those will both be composed of signal B. Signal C would be composed of these 2 hydrogens since they both have the same chemical environment. So those will be signal C, And signal D would consist of this last hydrogen environment over here. So this compound would have 1, 2, 3, 4 signals consisting of A, B, C, and D. Now, you might be like, wait a second, hold up. What about these double bonds? Well, there's a double bond here and a single bond here, and a double bond here and a single bond here. So there's no way that there's symmetry across this molecule. And my answer to that is that this is an aromatic molecule. And what that means is there's energy flowing all around the ring. Yes, there are double bonds in those positions, but technically we can move those double bonds over. So if we wanted to, we can redraw this molecule and draw the double bonds one position over, and it would still be the same molecule. And chemists know this, so much so that they actually begin to write the molecule with a circle in the middle to indicate that the energy is flowing all around the ring. So if you ever see an aromatic molecule with a circle in the middle, all that means is that you have this aromatic ring. Now take a moment to pause the video and try the following on your own. So for letter A, we want to identify the types of symmetry we have in the molecule. We have one plane of symmetry going down the middle this way. We also have a plane of symmetry going down the middle this way. And so we want to bear that in mind. What that means is this hydrogen environment will correspond to this hydrogen environment. And this hydrogen environment will correspond to this hydrogen environment. Likewise, it will also correspond to this hydrogen environment and this one. And you might be a little confused by that, but remember when I told you there was two planes of symmetry going down the middle this way. And so this hydrogen environment has the same chemical connectivity as this one. If we look at this one, for instance, we see that it's attached to another CH group and this carbon along with this methyl group. Whereas if we look at this one, we see that it's attached to another CH group and this carbon along with this methyl group. So we see that these two guys have the same chemical connectivity, just as well as these two guys. We'll call that signal A. So we have 4 signal A's. And we can call this hydrogen here signal B. And so this molecule has 2 signals. Let's go ahead and try the next one. So where do we have our planes of symmetry? Well, we know we have a plane of symmetry going down the molecule this way. Do we have any other planes of symmetry? Is there a plane of symmetry going down the molecule this way? No, there isn't. Otherwise, we would have had to have methyl groups attached to these 2 carbons. And we don't have that. Therefore, we are working with one plane of symmetry going down the molecule this way. And so if we highlight this hydrogen environment, we know that it's going to correspond to this one. Similarly, this hydrogen environment will correspond to this one. Now, let me ask you, does this hydrogen environment correspond to this one? No, it doesn't. Because remember that the plane of symmetry goes down the middle. So this hydrogen will have its own chemical signal, and this hydrogen will have its own chemical signal. Therefore, if we call this signal A, signal B, and signal B, and signal C and signal D, we'll find that this compound has 4 signals. Now let's go ahead and try the last one. We know that we have a plane of symmetry going down the molecule this way, and that's the only plane of symmetry that we have. We can go ahead and highlight this hydrogen environment to correspond to this one, whilst this one will correspond to this one, and finally these two will correspond to each other. And that follows through with that plane of symmetry we had drawn in earlier. So if we call this signal A, this will be signal A, this will be signal B, and this will be signal B, and these two will be signal C. So here we have 3 chemical signals. So that's it for this video. If you liked it, please leave a thumbs up and feel free to subscribe. Happy studying!